So now let's do some practice transcription. When we had DNA, the complementary base pairs were A and T and C and G. But remember, you don't have a T in RNA. So the complementary rules are as follows. If there's an A in the DNA strand, then the mRNA is going to have a U. Remember, A and T were complementary, but there's no T in RNA, so that U is the same. C and G, T will still go to A. C will still go to G, and G will still go to C. So when we are transcribing, these are how the complements will line up with each other. So if I were to give you a strand of DNA, and let's say, and I'm just going to show you one side, because remember you only transcribe one side. So if this was the set of nucleotides on one side, and let's say this was A, C, A, T, T, G. So this would be an adenine, a cytosine, an adenine, a thymine, and a guanine. So remember, DNA is made up of A, T, C, and G. If we were to transcribe this strand and make a primary mRNA, then the things that would line up opposite it, A would end up next to U. So the complementary base pair here would be a U. The complementary base pair here would be a G. Another U. Opposite T would be A. Opposite T would be another A. And opposite G would be a C. So when I talked about in that previous assignment, when the complementary base pairs, we opened up that DNA strand before DNA polymerase or RNA polymerase can do its job, the complements have to line up opposite each other, and then the RNA polymerase can come through and make a phosphodiester bond between them. So part of today's assignment is, if I give you a DNA strand, can you find and create the mRNA opposite that? So if we had a bigger strand, so here's another strand. So and I just make these up as I go along. This isn't any particular sequence. If this is the DNA strand, what would be the complement and the mRNA that would come from it? So opposite C is G, opposite G is C, opposite A is U, opposite T is A, U, C, C, G, U, A, U. And so we can draw out these nucleotides. And so the mRNA strand that would be created from this segment of DNA would have this composition. They have found their complements. Now remember, the second part of mRNA is mRNA processing. Another term you're going to need to know is that every 3 letters of the DNA is called a codon. So I didn't spell that well. So C, G, and A in this strand is a codon. TTA is a codon. Every 3 letters of the DNA is considered a codon. So this particular DNA strand has 4 codons. So remember this here, this is my transcribed mRNA molecule, or a primary mRNA molecule. If I were to give you instructions and say that the second codon is an intron, then we could process this mRNA and make it into a mature one. So if the second codon is an intron, remember introns are removed. So that means these 3 letters, because remember this is the second codon, 1, 2, 3, 4, the TTA is that codon. The part of the mRNA is AAU. So if I say the second codon is an intron to process this, we would remove those letters. And then we will put everything back together just as it was. But now all we have is G, C, U, and then we skip over to here because we've taken this out. C, G, U, A, U. And then that spliceosome would bring those together. And then don't forget, also part of processing, we're going to stick another G on the front. This is my guanine cap. And we're going to stick some A's at the other end. And this is my poly-A tail. I have now taken my transcribed mRNA and I have made a mature mRNA. So transcription will first make a transcribed mRNA. A transcribed mRNA will then be converted into a mature mRNA. We will remove any introns, and I will just give you the instructions for what is an intron. You don't have to, there's no special thing in any particular sequence that tells you something's an intron. It's just something I tell you. You will then take that intron out. You will add a guanine cap to one end and a poly-A tail to the other end. So let's do one more. So this one will be a little bit longer. So if I start off with some DNA, in my DNA, let's do so this is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Actually, I'm going to do this in a little bit different format. The way you're going to see it on the assignment, it's going to look a little bit more like this. I'm just going to give you a set of letters. So you'll have to imagine the lines being there, and what I do is so that you know where the codons are easily. Notice I've written the DNA in sets of 3. So you can think of this being, the line back there with the little things attached. We really don't need to show that each time. We just need to know that in this DNA sequence, we have 15 nucleotides, and we represent them by the nitrogenous bases. And then I've grouped each one so that you can see the codons easily. So these 15 nucleotides, making up one sequence of the DNA, can be categorized as 5 different codons within that. So by putting that little space there, it's easy to see the codons. So therefore, if we were to make the primary mRNA, the transcribed mRNA, we would go with opposite A is U, opposite T is A, opposite C is G. And I'll also write these in the sets of 3 so that you can easily see them. So the primary mRNA, the transcribed mRNA from this DNA sequence, A goes to U, T goes to A, C goes to G, G to C, G to C, C to G. We still have 15 nucleotides, but now we have RNA nucleotides. So this is going to be the transcribed mRNA. So now let's process this. So during the processing, I will tell you what the introns are. So codon 3 and 4 are introns. So 1, 2, 3, 4, 5, that means introns get taken out. Everything else just gets put back together. We're just going to squeeze it like an accordion. But we're also going to add our cap. So we'll put on our guanine cap. Then we will put what's left of the transcribed mRNA and then we will add our poly A tail. So now I have created a mature mRNA. This mature mRNA can now go and find a ribosome to be transcribed. So you don't have to flip anything here. A goes to U, but you don't go back. Notice U is still U, A is still A, G is still G. All this does in the processing is cut out parts, but it doesn't change what's left. It just cuts out certain parts. So from DNA to ANA, you need complements. But from a primary mRNA to a mature mRNA, you just need to cut things out, add a guanine cap, add a poly A tail.